You think you understand what weight is? Mass, the amount of stuff you're made of. Atoms stacked together. Simple. Step on a scale. The number tells you how much matter is in your body. More atoms, more weight. Fewer atoms, less weight. Okay, explain this to me. Does a hot cup of coffee weigh the same as a cold one? You'd say yes. Obviously, the water is the same water. Same atoms. Same amount of matter. Wrong. The hot coffee weighs more. Not because you added water. Not because you added atoms. Because you added heat. And heat has weight. That doesn't make sense, does it? Temperature is just how fast molecules vibrate. Movement doesn't weigh anything except it does. Einstein proved it. The most famous equation in physics, E ex mc squared, says energy has mass. Not metaphorically, not poetically, literally, measurably. Every joule of energy you add to anything adds mass. And that means like now, reading this, the warmth in your body is making you heavier. Not by much, but by a real, calculable, physically meaningful amount. The equation on the coffee mugs is describing your body right now. Let me show you what Einstein actually discovered. The standard explanation of E h mass squared goes like this. Matter can be converted into energy. That's what happens in nuclear bombs. That's what powers the sun. Tiny amounts of mass release enormous amounts of energy. You learned this in school. It's not wrong. But it's backwards. Everyone focuses on turning mass into energy. The bomb, the explosion, the mushroom cloud. Almost nobody thinks about the reverse. Energy turning into mass, heat becoming weight, motion becoming matter. But the equation works both ways. That's what the equal sign means. E ex f squared. Energy equals mass times the speed of light squared. Flip it around. M E equals E squared. Mass equals energy divided by the speed of light squared. Add energy to anything, heat, motion, potential energy, any kind at all, and you add mass. The reason nobody talks about this? The speed of light squared is enormous. 290 T 40 meters per second squared. That's about 90 quadrillion. So ordinary amounts of energy translate to almost immeasurably tiny amounts of mass. Almost immeasurable, but not zero. Never zero, never zero. And here's what Einstein understood that most people miss. This isn't a special case. This isn't about nuclear reactions. This is about what mass is. Let me start with something you can picture. Start with something simple. A pot of water on a stove. Cold water, room temperature, about 20 degrees Celsius. Put it on the burner, watch it heat up, watch it boil. What did you do? You added heat, thermal energy. You made the water molecules move faster, vibrating, spinning, colliding with more force. The water looks the same volume, same atoms, same atom, molecules. You didn't add anything to it. You didn't pour more water in, but you did add something. Energy. About 420,000 joules to bring a liter of water from room temperature to boiling. Now here's the question nobody asks. Does that energy weigh anything? Pause. According to Einstein, yes. According to the most tested equation in physics, absolutely yes. Take those 420,000 joules, divide by square, divide by 90 quadrillion, you get about 4.7 times 10 squared kilograms. That's 0.47 kilograms, 4.5 trillionths of a kilogram, undetectable by any kitchen scale, undetectable by any scale you've ever used. But real, the boiling water weighs more than the cold water, not because of added atoms, because of added energy. The heat itself has mass. Here's what should bother you about that. The heat didn't come from nowhere. It came from the stove, from burning gas or electrical resistance. That energy had to come from somewhere. Trace it back far enough. And most of Earth's energy comes from one place, the sun. The same mass energy equivalence that makes your hot water heavier is the reason the sun shines at all. The sun converts mass into energy through nuclear fusion. That energy travels 93 million miles. Some of it ends up as heat in your pot of water. And now that energy has mass again. But that's just the surface. Because if heat has mass, then everything starts to get strange. Dashley Fall wants the AC accessible explanation. Let's make this concrete. A hot object weighs more than a cold one. Any object, every object. Your morning coffee weighs more when it's steaming than when it's cold. By trillionths of a gram, but more. Your car engine weighs more when it's running than when it's cold. The thermal energy in those pistons and cylinders and coolant? Mass. Your laptop weighs more when it's working hard than when it's idle. The heat from the processor, the energy stored in RAM, the motion of electrons, all mass. This isn't philosophy. This is measured physics. In 2005, scientists at the National Institute of Standards and Technology heated a sample of silicon and measured its mass change with an atom interferometer. The result matched Einstein's prediction exactly. Heat added mass, E equals squared held. But wait, that raises another question. If heat adds mass, what about other kinds of energy? Asterisk level 2, going deeper. Here's where it gets strange. A compressed spring weighs more than a relaxed spring. Stop and think about that. You take a spring, you squeeze it. You've added potential energy stored mechanical energy ready to push back. And that potential energy has mass. The spring didn't gain atoms, but it gained weight. Same with batteries. A fully charged lithium-ion battery weighs more than a dead one. The chemical potential energy stored in those electrodes? Mass. About 1000 square grams for a phone battery. Unmeasurable with normal instruments, but real. Same with magnets. Two magnets stuck together weigh less than when they're held apart. That one should break your brain a little. When magnets snap together, they release energy. You can feel it, hear the click, sense the force. That energy has to go somewhere. It becomes heat in your hand, sound in the air, vibration in the magnets. The energy left the system. And with it, mass left the system. Pull the magnets apart again, and you're adding energy back. You're adding mass. Here is the thing that most people miss. This isn't three different phenomena. Spring compression, battery charging, magnetic separation. These are all the same thing. Energy is mass. Add energy, add mass. Remove energy. Remove mass. E-expat isn't about nuclear bombs. It's about everything. But we're not at the bottom yet. There's another layer. And this one is going to change how you see yourself. Asterisk level 3. The fundamental truth. Now we're getting to the core. You are made of atoms. Atoms are made of electrons, protons, and neutrons. Protons and neutrons are made of quarks. Two are quarks and a down quark in a proton. Two down quarks and an up quark in a neutron. Here's the question. How much do those quarks weigh? The answer should break your brain. All the quarks in your body, every single one account for less than 2% of your total mass. Read that again. The fundamental particles, the actual stuff you're made of, the irreducible building blocks at the bottom of physics, they contribute almost nothing to what you weigh. So where does the other 98% come from? Energy. The strong nuclear force 1 of the four fundamental forces of nature holds quarks together, inside protons and neutrons. That force is unimaginably powerful. It creates a field of gluons bouncing between quarks at nearly the speed of light. That field has energy, enormous energy, and that energy has mass. When you step on a scale, you're not measuring how much stuff you contain. You're measuring how much energy is trapped inside you. Your mass isn't from matter. Your mass isn't energy. This is what Einstein discovered. This is what E as in squared actually means. Mass isn't a fundamental property of particles. Mass is energy, compressed and bound by forces manifesting as weight. You are not made of stuff. You are made of trapped light, frozen energy, force fields bound in the stable patterns. And every time your temperature changes, every time you absorb a photon of light, every time your heart beats and your muscles burn fuel, the amount of energy inside you changes, which means your mass changes. You weigh more when you're hot. In your normal experience of the world, mass and energy are separate things. Mass is stuff, solid, permanent. You can count atoms. Energy is activity, motion, heat, force, immaterial. You have mass. Energy is something you use, except that's completely false. Pause. There's no distinction between mass and energy. They are the same thing, measured in different units, like measuring distance in miles versus kilometers. Different numbers. Same reality. When you eat food, you're not getting energy from mass. You're rearranging the energy, that vast mass, into different configurations. Some of it becomes thermal energy and radiates away. You literally become lighter, not because atoms left, but because energy left. When you exercise and heat up, you're converting chemical energy in your muscles into thermal energy in your tissues. The thermal energy weighs something. You get temporarily heavier. Let me prove it. Your body temperature is about 37 degrees Celsius. That's 98.6 degrees Fahrenheit. The thermal energy keeping you at that temperature, keeping your molecules vibrating at that speed, accounts for a tiny but real fraction of your weight. If we could cool you to absolute zero, which would kill you, but theoretically you would lose mass. Not atoms, mass. The energy that was making your molecules vibrate would be gone, and it would take its weight with it. How much? About 10 kilograms, 100 trillionths of a kilogram. Unmeasurable with current technology, but not zero, never zero. Think about what that means. When you have a fever, you weigh more. The extra thermal energy pushing your temperature from 37 degrees Celsius to 39 degrees Celsius has mass. When you step out of a hot shower, you weigh more than before. You got in not from water on your skin, but from heat in your tissues. When you're angry and your metabolism spikes, when you're exercising and your muscles burn, when you're thinking hard and your brain consumes glucose, your mass fluctuates. Not because atoms enter or leave your body, because energy does. You have never been a fixed amount of matter. You are a standing wave of energy, constantly gaining and losing mass with every breath, every heartbeat, every thought. Here's the quotable version. The one that should stick in your mind. Asters, your weight is not how much stuff you're made of. Your weight is how much energy is trapped inside you. This isn't a metaphor. This isn't poetry. This is measured, tested, verified physics. Einstein published this in 1905. We've confirmed it to 11 decimal places, the boundary between mass and energy that you always assumed exists. It never did. Now here's what people miss when they learn just about heat and weight. This isn't an isolated curiosity. This is how the entire universe works. The same mass energy equivalence that makes you heavier when you're hot also powers the sun. The sun fuses hydrogen into helium. The helium weighs less than the hydrogen that made it. The missing mass became light. That light traveled 93 million miles and is warming your face right now. Mass became energy, creates new particles. At CERN, scientists accelerate protons to 99.9999991% of the speed of light and smash them together. The kinetic energy, pure motion, creates new particles. Higgs bosons, quarks, antimatter. The energy becomes mass. We photographed it. Explains why nuclear weapons work. When uranium-235 splits, the fragments weigh less than the original atom. That missing mass, about 0.1%, becomes the fireball. 1 kilogram of uranium fully fissioned releases as much energy as 20,000 tons of TNT. That's EX miscarried in action. Makes antimatter annihilation possible. When an electron meets a positron, they both vanish. Two particles with mass disappear entirely and become two photons of light. Mass becomes pure energy. Nothing left but gamma rays. The same equation, the same equivalence every time. What looks like many different phenomena is actually one thing: energy converting to mass, mass converting to energy. The universe endlessly transforming itself from one form to another. And you're not separate from this. The energy bound up in your protons and neutrons, the 98% of your mass that comes from muon fields and strong force interactions, was created in the Big Bang, forged in stars, scattered by supernovae, and reassembled into you. You are recycled stardust, sure, but more than that, you are recycled starlight. Energy that became mass billions of years ago passed through generations of stars and is now temporarily arranged in the shape of a person reading these words. The warmth you feel right now, this energy with mass. The thoughts firing in your neurons, electrochemical energy with mass. The heartbeat keeping you alive, mechanical and thermal energy with mass. You are not solid matter experiencing energy. You are energy experiencing itself as solid matter. That's what EX from skull actually means. So why do you weigh more when you are hot? Because heat is energy. Energy is mass. And when you add heat to a body, you add mass to a body. Not atoms, not molecules, not matter in the way you always understood matter. Energy itself. bound into your tissues, contributing its weight to your total. But understanding this isn't just about thermometers and scales. It's about what you are, what mass is, what the universe is made of. For most of human history, we thought mass was fundamental, the irreducible stuff of reality. You could have matter or you could have energy, but they were different categories. Einstein showed that was wrong. In 1905, a 26-year-old patent clerk published a paper showing that mass and energy are interchangeable, that Ex was no squared, that the distinction we'd always assumed was fundamental didn't exist. It took decades to confirm. Nuclear reactors, particle accelerators, atomic bombs, precision measurements of heated samples and charged batteries and compressed springs. Every test confirmed it. The equation holds. And it means something profound about reality. The universe is not made of stuff. It's made of energy, some of it bound up tightly enough to seem solid, some of it flowing freely as light and heat and motion. The chair you're sitting on, frozen energy. The device you're reading this on, frozen energy. You, frozen energy. When you heat up, there's more energy frozen in the pattern that is you. When you cool down, there's less. Your weight is not a fixed property. It's a moment-by-moment measure of how much energy the universe has chosen to bind into your form. The fact that we understand this, the fact that Einstein figured it out with nothing but thought experiments and mathematics is extraordinary. The universe is comprehensible. The deepest truths about reality are knowable. And one of those truths is this: you are not matter. You are energy, pretending to be matter. And the energy is what weighs. That's what mass really is. Not stuff, not atoms, not particles at the bottom. Energy bound by forces experiencing itself as solid. Not comfort, not simplicity. True. If this journey into Ex squared changed how you see yourself, not as solid matter, but as frozen energy, subscribe and share it with someone who still thinks mass and energy are different things. Here's a question for the comments. What other everyday experience do you think hides this kind of fundamental physics? What obvious phenomenon have we all stopped questioning? The universe is stranger than it appears. And we're just getting started.